Okay, so we're testing airfoils in a wind tunnel. So to do that, we have open here and stick our airfoil in here, connected to this frame that drops down below underneath to this load cell here, which then connects to the computer where we calculate lift force, drag force, and side force, and we can adjust the airspeed of the wind tunnel. So to start the test, click run here in the wind tunnel control panel VI, and then we tear all and that to calibrate it, and then we click start tunnel, which warms up the wind tunnel here, and then we can adjust the airspeed, and this is what the airspeed is going to, and this is what the current airspeed is. And then once it reaches airspeed, we click start data collection, and it will graph the lift force, drag force, and side force, and it will put it all into an Excel file for us.
Perfect. So some variables that we're going to have is a lift force, a drag force, and we're also going to be measuring the cord length. And so with this, we will have some sources of error, and one of those places is going to be coming from the load cell. However, we do have the uncertainties from different data tables in regards to that. And another area that we might face some error is just the angle of attack on our airfoil. And that will give us plus or minus 1 or 2 degrees. And another area where we might face some error is just our Reynolds number scaling using Buckingham Pi analysis. And just some ways that we can help prevent error is just a consistent instrumentation. So just make sure that we are keeping the airfoil at the same height with each test, as well as just trying to maintain a consistent angle of attack, as well as just tearing and calibrating our data.
As an aircraft flies, it produces a lift force. This lift force varies with velocity, drag coefficients, and the shape of the wing. With this lab, we're going to measure the lift force for different airfoils at different speeds. And from this, we expect to be able to plot these different lift forces for the different airfoils and for the different speeds.
Okay, with the wind tunnel, because we're going to be measuring multiple variables, it requires some calibration. We're going to be calibrating the load cell and the drag force measure thing to make sure we have our known calibrated amount of drag force. And because we're calibrating it, we'll know our errors, and then because we know our errors, that applies to the class because we can propagate all our errors and figure out a total error.
There aren't any gaps because this is used a lot and it's well set up. The maximum lift force was found using the maxed airspeed of the wind tunnel, which was 35 meters per second, and a cord length based off of the aspect ratio of each wing and an assumed coefficient of lift for each wing, and the max lift was found to be 100 newtons.